Namaskar. Today we are going to see for scanning electron microscope and the similar electron microscope and their applications and internal block diagram structures and all. First of all, the question arises to all of us why to use electron microscope, structure determination, morphology and topography. For these three important characterizations we need electron microscope. But what are the probes used in this microscope? There are different types of probes. First one is visible light optical microscope. Purpose we use X-ray, X-ray diffraction, X-ray photoelectron spectroscopy, neutron diffraction. There is also ion, secondary ion mass spectroscopy, cleaning and thinning samples, and other are electron microscope, in which we are going to study for scanning electron microscope, that is SEM. Next is transmission electron microscope, which is abbreviated as TEM, electron holograph, EH, electron diffraction, ED, electron energy loss spectroscopy, EELS, energy dispersive X-ray spectroscopy, EDS, which is mostly used in research purposes, and nowadays which is Auger electron spectroscopy. In all these microscopes we are going to study different probes of it. What is the scale in which these microscopes are works? Okay, we have electromagnetic spectra. In that electromagnetic spectra we have XRD, TM range, SEM range and OM range. First of all, we want to determine for crystal structure, their macrostructures, grain 1, grain 2, the arrangements of atoms and different gains and their gaps like pores and a component wall turbo charge. We also have the scale of from which range to which we are going to find out the measurement, which is starting from 10 raised to minus 10 meter to 10 raised to 1 meter, that is from basic research to the applied research. Atomic microscopy to macroscopic level we are going to find it out. Okay, so that the dates where these microscopes were invented and started in a public use, which as the transmission electron microscope was the first type of electron microscope to be developed and is patterned exactly on the light transmission microscope, except that a focused beam of electrons is used instead of light to see through the specimen. It was developed by Max Knoll and Ernest Ruska in Germany in 1931. So almost it is 100 years of invention of TEM. So second, the first scanning microscope, first electron microscope, that is SEM, debuted in 1938, which is by Hon Ardini, with the first commercial instrument around 1965. Its late development was due to the electronics involved in the scanning the beam of electron across the sample. So next we are going to move for electron microscopy. When the electron microscopy started and its history. Electron microscopes are scientific instruments that use a beam of energetic electrons to examine objects on a very fine scale. And electron microscope were developed due to the limitation of light microscope, which are limited by the physics of light. Next point is, in the early 1930s, this theoretical limit have been reached and there was a scientific desire to see the fine details of the interior structure of the organic cells like nucleus and mitochondria, etc. It has a capacity of 10,000 x plus magnification, which was not possible using the current optical microscope, which uses light as a main parameter for the getting informations. The structure in electron microscope we get that we bombard electrons on any solid sample. In that we see the solid electron solid interaction. With this interaction we have come across the many phenomena like incident backscattered electron, cathode luminescence, secondary electron, elastically scattered electron, inelastically scattered electron, unscattered electron, and there is an again generation of X-rays and Auger electrons. In ahead slides we are going to see all the details about this all type of electrons which is produced due to the incident electron beam. And this electron beam, when interacted with the solid materials, these different types of electrons we came across to know. We can divide the signal into two broad categories like electron signal and photon signal. Comparison of optical microscope, transmission electron microscope, that is TEM, and SEM, scanning electron microscope. So here we can see the cross section of light microscope, electron microscope, and scanning electron microscope. In light microscope we can see that there is a light source. In that light source we use condenser to focus the light. There is a specimen, objective, and at the last eyepiece, and after that we can observe a zoom capacity that we can observe our required specimen or objective. In electron microscope, that source of electron is attached over the first point. After that there is a magnetic field which is provided by magnetic lenses. These are the lenses where we can direct the beam of electrons at a proper position. After that this beam of electron is projected on the specimen, and at last on the photographic film we can get the image of that specimen on the fluorescent scheme. After coming that scanning electron microscope, here we also use the cathode ray tube, that is here we bombard the photons. This is also guided by the magnetic fields to project this cathode rays on the specimen which is at the sample space, and after reflection or a refraction through that specimen, detector detects the refracted photons, and which is shown by on the cathode ray tube, that is CRT. Main principal feature of this optical microscope, a transmission electron microscope and a scanning electron microscope, drawn to emphasize the similarities over all design. So one by one we see all of these electrons. So first we see the electron microscope. This electron microscope uses electrons instead of light to form the images. So this is our first optical microscope. In labs commonly seen optical microscope seems like this. It has objective, eye lens, a different zoom resolving power, nose pieces. An objective is situated between our eyepiece and our light. There is at the bottom there is a light source also available. Light microscopes are unknown when first invented, but probably in between 1590s and 1610 AD. It can magnify up to 1000x, shines light through the object and projects the image through the series of lenses that magnify the image, and that is very cheap, or we can say the relatively inexpensive. What are its uses? Great for studying live microscopic organism, great for studying cells and tissues in general, widely used in hospitals and clinics to diagnose the disease, and now also used as a confocal microscope in nanoscience. What are the merits of electron microscope? There are two merits here given, that high magnification at high resolution. Technique is largely standardized. What are the drawbacks of EM? Equipment expensive, procedure time consuming. Yes, obviously it takes too much time depending on our sample. Small samples lead to possible sampling error and misinterpretation. That is a very common error. Much experience is needed for interpreting the result. Optical versus SEM, which one is better? Well, obviously instrument has its own advantage and disadvantage. SEM has numerous advantages over optical microscope. Like SEM magnification, optical microscope has magnification of 1000x, where SEM has magnification of 1 lakh or 100,000x. Resolution is also there, 0.2 micrometer resolution for optical microscope and 0.005 micrometer, that is electron microscope is always much better than the optical microscope. Similarly, there are depths of focus, sample preparation and all. So this is an image for a scanning electron microscope at a glance, where on the left side of the cylindrical point we can see that over here. So this is a sample preparing an electron gun over there. This is a sample holder and the whole output is seen on this computer screen. This scanning electron microscope first invented in 1942. It can be magnified up to 10,000x, gives a 3D image of the surface of the object. Again, a beam of electron is used instead of light. Electrons that bounces off the object create the image. The microscope scans a certain region of the object multiple times and then combines multiple images to create what when then seen on the computer monitor as one 3D image. No slicing needed, so easier to prepare samples. Larger objects can be viewed, but there is a drawback that it is very expensive, obviously. There is another electron microscope that is very too much expensive than a scanning electron microscope, that is known as transmission electron microscope. This microscope can be seen here in image. At the bottom over here we put the sample, and this table over there is a photographic plate, and we insert electron beam from this top and monitored over the way applying magnetic field with different directions, and we get final image at the photographic plate. First, this transmission electron microscope is invented in 1931 in Germany, can magnify up to 200,000 times x and beyond, similar to the light microscope except that a beam of electron is used instead of light. The electrons that penetrate through the object and creates an image which is then enlarged and then viewed on the computer monitor. Samples of the object must be sliced very thin before using the TEM. Here we have to take a precaution of making sample. Sample making is very tough in a transmission electron microscope, and there is a condition that the sample not be in a living specimen, because we have to penetrate electron beam throughout the sample, and which causes any live specimen to be in a dead condition. So we only use non-living things as a sample, but this is very expensive and time consuming to prepare a slides. What is scanning electron microscope? Here is another diagram of TEM and SEM. There is a common thing over here. In SEM we take output as a reflected electrons, but in TEM we take output as a refracted electron, that is electrons beam is passed throughout the sample, but in SEM the electrons are get reflected, and reflected electrons we collect by a detector which is CCD and provide output to the monitor. There is another diagram of scanning electron microscope. We can observe here the image of specimen and respective EDAS diagram over here. This is the example of spider which is put inside the scanning electron microscope, and the image of spider with a 100 times x of this we can observe where each part, eyes, mouth and every body part of the spider. Here we can see the depth up to which EM or electron microscope can probe. There is for the one particular microscope which is known as Okayama depth penetration. This is a particular type of scanning electron microscope. There is a formula to which it depends upon the accelerating voltage. So if we increase the accelerating voltage, the depth of that electron beam increases. We can see on the screen there is a formula also over there, which where R stands for depth penetration, A stands for atomic weight of that sample, is the electron beam energy, Z is atomic number of that sample, rho is the density of that sample. Okay. So these are the some outputs which is taken by scanning electron microscope. So first one is brittle gray cast iron image of 100,000 x zoom. Another one is a ductile iron. Simplified principle of the SEM. We can see detector over there and the direct image of the sample. This is layout of scanning electron microscope gun. There is lenses in the form of magnetic fields to direct the beam of electron which is incident on the sample, and the reflected electrons or reflected radiations are again detected by some sample and provided to the amplifier which is shown on the CRT. Today now we stop here. We will continue on the next part of this lecture. Thank you so much for your time. We continue for these lectures. Thank you. Stay happy.